Hey there. So this question is asking us to evaluate and simplify the difference quotient. And so that is a formula, which, where did I put it? Oh, there it is. Let me get rid of this one. That is this formula in the 1.2 notes. And so here's the difference quotient. So the difference quotient is defined as this function, and what it does is it finds the slope of the function. Which is way more interesting in another couple sections when the functions are curves, because then the slope at any given point is changing. For these ones, like this example, which is the one we're about to do, you can look at this and go, the slope is 3, and that's what the difference quotient is going to come out to. That won't work in another chapter or so, so we'll go ahead and see how to set this up for that. So this one is f of x equals 6x plus 6. Okay, go over here. So we are given, actually let me make this a little bigger because these get kind of giant. Okay, so we're given the function f, there we go, f of x equals 6x plus 6, and asked to evaluate that in this difference quotient, which is defined as f of x plus h minus f of x all over h. What this little bit of math ends up being is the definition that kind of motivates all of first quarter calculus. And so when you take calc, you'll end up using this in the first chapter of calculus, and then they'll teach you much better ways to solve it later. But this is going to end up, in this class, we're just using it as practice with function notation and functions. But it really does end up doing some stuff later in math, and we'll see it again this quarter. So what this is saying is this piece right here says f of x plus h. So whatever is in these parentheses, that is going to go into this x. So like the same way that if this said f of 7, you would go 6 times 7 plus 6. This says f of x plus h, so that is going to look like 6 and then x plus h plus 6. So that piece is our f of x plus h. And we're supposed to subtract from that. Remember, whenever you subtract, always open a parenthesis so that you get all the pieces subtracted. We're supposed to subtract from that f of x, which is just the original function. And then all of that is going to be over h. And now we have it set up, and we just got to clean it up and simplify. So we'll distribute that 6 through the parentheses, and that's going to get us 6x plus 6h plus 6 minus, distributing that negative through, 6x minus 6. That is all over h. And then a bunch of stuff should cancel. So here we have positive 6x and minus 6x, so those are going to cancel out, and plus 6 and minus 6, so those are going to cancel out. So now I'm left with 6h over h. I can reduce the h's. That should always happen if you do this right. And we're left with 6. And like I said at the beginning, the difference quotient on a linear equation, not very exciting, because the difference quotient, this is really, it's a fancy form of m2 minus, I'm sorry, I did not mean that. I had m on the brain when I did that. Sorry. It's a fancy form of y2 minus y1 over x2 minus x1, but in function notation. So all this is doing is finding the slope, and there we are. We got 6, and of course the slope should be 6. Again, this will get more interesting when we have quadratics and the slope isn't constant. And like I said, it will be, you will see it again this quarter at least once, and then you're going to see it in Calc 1 for sure, since it's going to kind of drive the definition of the derivative. Hopefully that helped explain. Holler if you still have questions.